running workloads in Azure. So what we will be doing in this part, we are going to look at the different ways for us to make software run in Azure. So that's what we are going to look at, running workloads. Now to explain running workloads in Azure, I wanna go in and take an example application that I use more often, by the way, in my trainings. It's Ticketmaster. We all know Ticketmaster, I think. If you want to buy tickets for concerts, then you go to Ticketmaster. And well, if you look at an application like Ticketmaster, then what we could say about this app is that about 90% of the time, the application is not doing so many things. However, when all of a sudden we start selling popular tickets, then we can see an increase of the load, and we can see a decrease when all the tickets are sold out. And then from that point on, everything is going to be a little bit more basic again. So we could go and say, hey, this is the load that we are running against the time that we are running it. If you would be owner of Ticketmaster, and if you would have to host the Ticketmaster solution yourself, then you would have to purchase hardware, and you would have to purchase around this, right? Because you want to be able to handle that peak. However, 90% of the time, you are not using the hardware that you have paid for. Ticketmaster is one ideal application to run inside a public cloud platform. Because what you do in a public cloud is you go say, hey, I'm going to run the amount of resources that I need. And if I notice that my resources need to be more because we can see an increase of the load, you can then go in and say, hey, you know what? I'm just going to add a couple of more resources. Oh, still not enough. Add a couple of more resources. Still not enough. Okay, add a little bit more. Then we see it's enough. And then when we see a decrease in the load, we can go and say, hey, maybe here we can now go back gradually to that base level of resources that we're going to use. And oh no, oh no, oh no, no. Ah, that sucks. Sometimes, and sometimes, sometimes when I hit the wrong buttons on my computer, well, that is what happens. I lose the picture. So again, just a quick short. So we can see sometimes we see an app that requires like a more bumpy way of being working. In Azure, we can customize the amount of resources to match the load that we require. And sometimes, if it's not enough, we can just go in and say, hey, you know what, like this, we can go in and, for example, choose to run more or less resources. We can be more flexible in that case. And Azure is ideal for this because in Azure, you will not have to pay for purchasing all your hardware. So you can just switch on and switch off resources or create and delete resources in a very, very, very flexible way. Now, if we think about running workloads in Azure, we think about running applications in Azure. And the person who has to create the application is the developer. So what I'm going to do here is I'm going to try and draw a developer. So you can recognize developers because they're wearing glasses, right? Well, they have eyes, right? That's what they do. Developers are people that, well, let's say this is a developer. Maybe just to be sure, this is the dev. Now, when a developer creates an application, then this developer can actually go and create applications in different ways. One way for a developer to create an application is to create just the full application. So if I would think about, for example, an application like Ticketmaster, then if you would look at this application, then the user will first have to log in to the app, and then we have to select whatever we would like to select. So we have to select the tickets. Then there's some payment component for those tickets, and then the tickets need to be delivered, right? There is some kind of a delivery situation happening. Maybe we create a QR code for people to access the concert or whatever. Now, you could create an application as a whole app, meaning then that these four different, so the four different components of the applications are being created in a single code base. They are being well created to be a full application like this. So this might be one application being compiled into a single app, right? This is one way to run applications. Now, what you will notice is that nowadays developers also can deploy or create applications in the form of so-called microservices. And basically what we do in microservices is that we can sort of separate the different components that make up the app into smaller pieces. So that means that we have the login component is one code base. We have the select component, the payment component, and the delivery component. Those are different pieces of the solution. One of the benefits from working with microservices is that you can basically treat individual components, individual microservices, as separately manageable components. So if you think about something called the CI/CD component, which is continuous integration, continuous deployment. Um, we can be the idea behind this in microservices is that we can be more flexible in when it comes to updating or upgrading the versions of your software. We can replace the select component without touching the other three, for example. Another way to host applications or to create an app, being the developer, is that we can also run or create applications as functions. And basically what that means is that we're going to divide each component into even smaller pieces to run the app. So a function component, in this example, when it comes to signing in into an application, we could have one function that is about receiving the credentials from a user, to verifying the credentials, to assigning certain permissions for that user. The idea behind functions is that these are typically very small and so-called short-lived pieces of code that runs on triggers. Small, short-lived, triggered pieces of code. So when we need it, we run it, and that's it, right? When we need this piece of code, we connect to it, we run the piece of code, we get the responses, and then we move forward. Where the other two in containers and also in microservices and applications are more like a process that keeps on running as long as there is use for it, right? That is a little bit different approach. So the developer here basically can go into three different ways of hosting applications or creating applications. And in Azure, we have three different ways of hosting those apps. So for example, if in Azure you want to run applications, like a full application hosting, then we can go and take two things. One of the ways to run an application one way is to run a virtual machine. So what we can do is we can create a virtual machine. Now, when you create a virtual machine, so this is, by the way, an infrastructure as a service virtual machine solution. You create a virtual machine, and there's a couple of things when you create a virtual machine that you have to think of. First of all, when you create a virtual machine is you need to think about the size. And this has everything to do with how much CPU power, how much memory, what kind of storage capabilities, networking capabilities, and even whether or not your virtual machine needs a graphical processor unit, GPU. That is some choices that you have to make. We have we have many different sizes when it comes to working with virtual machines. There's a lot of those. Now, there is one very nice resource that may help you a little bit with this stuff. If you go into the Azure calculator, then this tool is a tool that you can use to sort of calculate how much you expect to pay for Azure resources. Here we can basically go through all kinds of resources. Virtual machine being one of the more popular resources, you can go in and say, hey, you know, what does a virtual machine cost? Well, first of all, here we have a list of all the different virtual machine sizes. And here we see, for example, virtual machines that go from 1 CPU to 2 to 4 to 8, 16, 32, 48. And if I go down further down enough, you will see that there will be virtual machines that can go up to 96 cores here. But even further than that, we have 144 cores that you can look at. And I think the virtual machine with the most amount of cores to work with is 448 cores or something. It's like if you spend enough money, you can get like very big virtual machines. Just like that, we can also think about a memory. Here, for example, we have 72 gigabytes of RAM. But there's also virtual machine that allow you to get like 12 terabytes of memory here. Here we have 112 CPUs. There's also storage capabilities, like how many data disks can it handle, or how many IOPS. So how fast are we able to communicate with the storage? There is many options. I can imagine that the amount of options is a little bit too much for what you can think of. However, if you need to choose the right VM, there's also a little tool that we can access from here, and that is the virtual machine sizer, or the selector utility. Basically, what we can do here is we can then find virtual machines by workload, and here we can tell, hey, what kind of virtual machine do we need? Because what is our workload going to be like? Are we going to use compute intense, memory intense, storage intense, GPU, or high performance compute? And just like that, we can also make choices like, hey, how much CPUs do I have? Oh, see, the maximum amount of CPUs now is 896. So let's say I need a virtual machine that has 896 CPUs here. So let's say that's what I want. The maximum amount of RAM is 30 terabyte. All right. So these computers are insane. Let's say this is what I need. Then we can see that there is one virtual machine size that makes sense at this point, right? So there's only one VM that can handle this. And let's say next, what kind of storage do we need? What kind of data disks are we going to add? Different kinds of SSDs here. Are we going to run Windows and Linux? And what are we going to run there? Where do you want to run it? Let's say I want to run it in the United States, and then we can see the different regions in the United States. And here we can see that this is a virtual machine, which is the most expensive virtual machine you can think of. And this virtual machine will cost you $299,592 per month. Whoa. Let's add that into my calculator. Let's just go and make this happen. So let's click that button. And here I think, no, yes, I was hoping that this would do. Oh, it's down here. Then, oh, my face is in the way. No thanks. Let's try again. Calculator. Then here we can go and switch to that calculator. Okay, here we are. And now we have, well, it's not here to be. Is it down there? Ah, here we are. So this is the virtual machine, and probably, oh yeah. Now I have added this like a couple of times. Maybe I should have been more patient here with this when creating this. Let's get rid of this. I'm gonna delete everything. Gonna try it once more, which will take me there, right? So here we have this one virtual machine, the M896 IXDS 32 V3. This is one big ass virtual machine. And as you can see, this will cost me in dollars in this example because I have chosen East US here and I have the licensing and everything in here costs me $329, $679 $1,000, 600. So this is like an amazing amount for one single month. Now you can imagine that if I want to save some money, I may not need DVM the entire month, right? So I could do some, hey, maybe I only need it for 1 hour per month. Then I will pay $451 for this 1 hour, but I do have the biggest, the biggest VM I can run, right? So that is something you could do. So sometimes you want to run something for the entire month, you will pay full price. Now you can also choose to have half of the machine, and there's all kinds of calculations, but this is just an idea of how we can use that virtual machine selector to get to a certain VM. Of course, if you want to have a different setup, then here I may also be happy, let's say, with 4 CPUs till, let's say, 16. Maybe I want to be somewhere between 4 gigabytes and 64 gigabytes, right? In that case, I have 135 different options. I can choose. I can look for some extra features like, hey, do I need a GPU, right? I think I want an Intel processor here. Do we need a GPU? Yes, I need a GPU. So these kinds of questions I can answer, and that will all affect the amount of options that I have at this point, right? So if I'm going to change to AMD, it's going to be 7. If I don't really care, I have other options, right? So just like that, we can choose whatever kind of VM we like, different settings, and so on. So you have to think about the sizing first. Second, you're going to talk about the operating system. In Azure, we have two options. We support either Windows or Linux, and that's the only options that we have. So you have the operating system, and there's a couple of other things that we also need to make sure that we have in place when it comes to well, working with these virtual machines. One of the options that we need to think of um, is availability. And one of the options that you could be implementing is virtual machines that are supporting availability zones, right? So we can go say, hey, you know what? I'm going to create 2 virtual machines. Both are going to be in West Europe, for example, but I'm going to create them in 2 different availability zones, meaning that if, for example, one availability zone goes down, for example, a power source in Azure goes down physically, or the networking goes down in some way, then my virtual machine can still keep on running in the other availability zone, which makes sense, I guess. Another option would be that we can make use of something called availability sets. Availability set basically means that all your virtual machines, you have more than one VM, but it's basically what we are using is a single data center. We are just going to make sure that our virtual machines are stored on different Hyper-V servers in Azure. That is another option. Typically, we could say that a single virtual machine, a single virtual machine, Microsoft says, hey, we have an SLA for this of 99%. Actually, it's 99.9%. That is the SLA service level agreement for a single VM. If you make use of availability zones, you get 99.99% SLA, where an availability set goes as far as a 99.95%, which is, as you can tell, a little bit less than 99.99. It's just getting you some extra availability. Another thing that we need to think of if we think about virtual machines, we need to think about scalability. When we think about scalability, we may have, maybe based on that peak, we need more virtual machines or less virtual machines depending on how much load we are running, how much load we have running that Ticketmaster app, right? So in scalability, we have two options here. One of the options is that we can make use of something called a virtual machine skill set. And this allows us to run somewhere between 1 and 1,000 virtual machines, VMs. And the scaling is based on monitoring, or based on this is basically a performance scaling that we are implementing at this point. Another option is that we can run something called Azure Batch Services. And Azure Batch Service allows you to run somewhere between 0 and virtually no limit in the amount of virtual machines. This is what we call trigger-based scaling. So there are solutions in Azure that run Azure Batch Services. And there are solutions where, for example, every morning at 5 a.m., companies are starting 64,000 virtual machines to do some calculations for, let's say, 30 minutes, 35 minutes, and then they shut down all of those virtual machines to save money because the calculations are done. One reason, for example, could be if you have to calculate the optimal route for, let's say you have to calculate the optimal route for these delivery trucks in a country to deliver the packages to the homes of the people ordering web shop stuff, right? Then Azure has these kinds of options. So if you look at virtual machines, then virtual machines are pretty much one solution to go in and host an application. So let's say you want to be hosting an app, then the app is here, right? So let's say this is the application that we want to be hosting. Virtual machines is one way. One of the main benefits for virtual machines is that you have full control to the operating system in that virtual machine, right? So the VM has an operating system, and because you have full control to the virtual machine, whatever is inside it, you can do whatever what you want to do with that operating system. So if your application needs a very special configuration, then a virtual machine might be what you need in order to be able to run the application. Another option to run software is not by implementing an infrastructure as a service virtual machine, but you can be looking into a platform as a service app service solution. Now, the solution of app services comes with two components. First, one component is something that we call an app service plan. And actually, the app service plan is a virtual machine. However, it is managed by Microsoft. So this is a Microsoft managed, MS managed virtual machine. So we don't get to touch it, basically. We don't get to see it as an actual virtual machine. We cannot use a remote desktop connection in it where with a virtual machine, we can do that, but in an app service plan, we cannot do that. So also here, we need to think about the sizing. We need to think about the operating system. We need to think about availability, however, and about scalability. However, we do have a lot less options to configure this because the solution is basically part of the app service plan because it is Microsoft managed. Now, inside the app service plan, we will then be running something called an app service. And the app service is basically a Microsoft managed web server. Is a MS managed web server. So if I chose, because I have to choose an operating system, if I would have chosen Windows, then the managed web server is Internet Information Server. If I'm choosing Linux, then it is an Apache server or an Nginx service. And on top of that, we want to be hosting our application here. So we can create an app like this. And then we go in and well, we can start hosting our web app. So if we don't need a situation that is so special that we can that we can just use, let's say, a lot of default settings, then an app service is an app service plan, and an app service is quite a useful situation to work with, quite a normal situation here. Where if you need more control, a virtual machine makes more sense. Now, before I continue, because we have other options, you can tell because there's a lot of white space on my screen, right? But before I continue, there is a big difference between infrastructure as a service and platform or software as a service. Infrastructure as a service, I'm just going to create a nice square here in the top right. Basically, what we say is infrastructure as a service components, they are designed for private use, where platform as a service, as well as software as a service here, this is designed for public use. That means this comes with an fully qualified domain name. So in Azure, let me show you what I mean here. So if I am in Azure here, let's go and kill my connections here. But let's say here I'm in an Azure environment. Let's first create a resource group. So here I have a couple of resources. I'm going to create a resource group with in a certain one of my subscription here. I'm going to name this my demo resource group like that. Let's just quickly create this. So this is going to be an empty resource group. There's nothing in there as we speak, not at the moment. But if I want to create a resource, let's say I'm going to create an app service. Then one of the things I can do is I can start by creating an app service plan here. I'm going to create this app service plan by, putting it in that demo resource group. I'm going to choose East US as the location. I'm going to choose, let's say I'm going to choose Windows here for the operating system. Can give this a name. And now I'm going to name this, let's say I'm going to name it AZ900, just like that. That's my app service plan. Or maybe let's go and say, hey, I'm going to name this my app service plan called demo. Can just give it a name. I'm running Windows, just fine. I can set up a pricing plan. So this is the sizing. So this talks about how much CPU power, how much memory, and so on are we going to choose for. I am going to choose, in this case, for a standard plan, standard one, like a cheap thingy, right? Yeah, that makes sense at this point. So let's do that. No, and oh, by the way, you can actually see the different pricing plans based on CPU, based on memory, storage, and so on. The pricing is here as well. You can also choose based on features. For example, some more expensive options, they allow for more backups daily, for staging slots, zone redundancy, virtual network integration, different options. As you can see here, we have different options. So let's say I want to go and select standard as one. That's the one I selected. This doesn't support zone redundancy, so for that, I'm gonna skip it. And then I can just go in and this creates that app service plan. You can see that there's not a lot of work for me here. And I'm not allowed to do it. Okay, sometimes you get an error. All right. So, this region has a quota of 0 instances for your subscription. So apparently my subscription doesn't want me to create this stuff here. This, by the way, may have to deal with my resource providers. So let's just go in here. Let's search for the resource providers. And now I'm going to search for a resource provider called Microsoft.web. I seem to be registered here, as you can see. So this is supposed to be all right. So if I then check out my quotas, I may need to go in and see how much of what am I allowed to create here. So here we can see that there is, for example, a limit of the amount of CPUs or virtual machines and stuff that I am allowed to create. Let's say I want to create an app service. No, app service plan, app service here. Maybe I just want to look for different options. I thought I would need to be working with the. I thought we would need to be working here with, let's say, compute stuff. But let's see if I can create something here. But what I wanted to show here is that there is some limitations in some cases, in some locations. You know what? I'm not going to try and create another one. Let's just go to a different universe here. Different tenant where I also have access, and I do know that I have an app service here. Actually, I have two. So let's say I'm going to check. So my MOAP website runs on an app service plan. An app service plan, like I mentioned, is like a virtual machine. You can see it has an operating system. This one is running Linux. I'm running Linux here. You can see that there is CPU use, there is memory use, there is data in, data out here as well. So it is being monitored in that way. But this is my app service plan. Here I may need to scale out or in. So here I can see that at this point I am running one single instance. Maybe I need two or three. This totally depends on the size that I have chosen, how big or how small I can allow this to be this to become. So that is out or in scaling. This is, for example, if my ticket master has a lot of things to do, I can add more instances. That is basically what it allows me to do. That is when we think about that app service plan. On top of the app service plan, we can create an app service. So if I check out the apps on my app service plan, I have two. I have MOAP, which is my MOAP website, and we have the Microsoft University website. Here, I haven't done anything yet. So for example, if I check out the URL, then this is what it is. But the interesting thing is, when you just create an app, it automatically gets this fully qualified domain name, which is publicly accessible immediately, right? Because we are running this as a app service, so, right? So that is one of those things that we want. So this is a Microsoft managed web server. Therefore, a lot of things are managed by Microsoft. Also, a couple of things are still something that we can configure ourselves. For example, we can create our own application settings. We can change little pieces here of the configuration. So even though this is managed by Microsoft, I can still choose myself whether or not I'm going to run my app as PHP or Java or .NET, what version of .NET, or if I want to use Python, what version of Python do you want to be using in this case, what is the startup command that you want, some other settings related to web services that we typically use, like the TLS, the HTTP version that we are going to allow here. Those kinds of things we can configure. Other things like path mappings or error pages. Now, this is not a lot of settings, but these are settings that allow us to configure the underlying app service. Now we can just go in and deploy our application, being the developer, deploy our application to this app service, and then we can start running the application. So this is a way for us to host software to run applications that would be run as a full app. So here we have virtual machines, we have app services that we could be running. Now, as we mentioned earlier, the developer could also go in and create the application as so-called microservices. Now, if you want to be running microservices in Azure, so microservices, then basically what we will be looking at is we will be running container containers. So this is container-based services, basically. Now, you might not be familiar with running containers, but you may have heard of something called Docker. Um, Basically, the idea is that the developer can create for each component that is part of the application. You can create something called a container image. The container image is just a piece of code, a file that we can run, and if we run the container, we will run the application. That piece of the application, that is container image. So what you could do is create multiple container images. For example, you may have a container image for people to log in, and you have one for selecting tickets, one for the payment module, and one for the delivery module. So here we have different container images. Now, if you would be zooming in into a container image, let's say this is zoomed in a container image, then basically what we have in that container image is we have here in this square, we have, let's say, the code that we want to be running. So what is the software code that we want active? And we have some operating system related settings that we are also putting in that image. So whenever we try to run that image, it has all the information it requires in order to be successful running. Then the developer can go in and say, hey, you know what? In Azure, we can create something. In Azure, we're going to create something called the Azure Container Registry. And basically what we do is we can just push those containers into the container registry. And the container registry is basically it's a location that we use to distribute the different container images to the solutions that need the images. So this is pretty much a distribution mechanism for containers. Um, and Azure Container Registry is often referred to as a secure distributor for container images. And then in Azure, we do have a couple of ways to run those containers. One solution is also a platform as a service solution that we run, and that is called that is something that we call container instances. The idea behind a container instance is that we can take one of those container images. Let's say this is our container image. What we can do is we can pull that image from the container registry. This is always a pull activity. And then we can see that Microsoft is sort of hosting a platform for us that we don't need to think about. So we don't need to think about. So this is a Microsoft managed platform, meaning we don't need to think about. So there's no sizing that we need to think of. There is no scaling that we need to think of. There's no availability choices that we have to think of ourselves. The only thing that we need to do here is we need to tell how much space that container requires. So we do some sizing here. For example, how much CPU or memory does the container need in order to operate? And then we can just run it, right? Without us having to do anything special. We have a container image, we want to run it, like a couple of smaller steps, and that will allow us to run that container. Let me see if I can, let's see if I can switch back to that tenant that I tried to create the app service in. Let's see if I'm allowed to create container instances here. So what I want to do is I want to create a container instance. Let's put everything in demo. I'm going to choose West Europe. That is close. Container instance demo, just a name that I have to make up. Let's see, I'm going to use a quick start image, so I don't want to be thinking too much, but I am going to run an hello world kind of solution, but I could also choose my own container registries here. The size of that image, so let's say I need 2 CPUs, I need, let's say 2 GB, and I don't need a GPU here. Then like this, I'm gonna allow access via port 80. Next, I will switch off the monitoring for now. No fancy things, just, go and see if I can create it. Let's hope. Yeah, this seems to be working, so let's go. And now I am creating so what I do is I have pointed towards a container registry, a public one. I chose a container image, and the only thing yet to do is I wanted to run this in a container instance. So my container here that I just pulled from somewhere will be run in that Microsoft managed platform. And the only thing that we need to think about is just communicate with it and then access the application. So let's uh, uh, um, let's have this created. Small drink. Mm. So with this, and this typically takes like a minute maybe. Sometimes it's a little bit faster, sometimes it's a little bit slower. Here we are. My deployment is complete. So this is my container instance that I am running here. You can see it has a public IP address because it's a platform as a service. So designed for public use, meaning we get a public IP address. And now I know I will probably be a little bit too fast because it needs a little bit time in order to be done. But if I go here and just pull this in, that IP address is pointing. Oh, it's working. So this is it, right? So this is the running. This is the running container. I know it doesn't do anything. That's what we call a hello world kind of application, but it runs. So it's here. It's active. That's it, right? So here we are. So this is just what you get if you. This is the most simplistic way of running a piece of code. We do have some other options as well. I want to focus on one more fancy one, and that is something that you may also have heard of at one point. Something called Platform as a Service, and then the full name is Azure Kubernetes Services. Now, Azure Kubernetes Services, which is, by the way, very often shortened to AKS, is also a container platform. However, it's a very much more advanced. So here we could go and say, hey, just this is a very simple container solution. Kubernetes is what we call a container orchestration solution, or a container orchestrator. The idea is that in a solution in Kubernetes, you have like different virtual machines that are mentioned as nodes. One of the virtual machines is a master node that is for management. That's the orchestration bit. And then there will be created something called a virtual network, and it will connect different machines to each other. These virtual machines are all part of a cluster. So here, this is virtual machines connected to a network, and each virtual machine, let's say this is node number one, each virtual machine can run containers, right? So you may be running a container here, and another one, and another one, and another one, and maybe this is just allowing you to, oh, that's not outside of the VM. So this can run all kinds of content. Now, how difficult is this? Apparently my mouse is now getting sensitive. Here we are. So we can run all kinds of containers, and there is going to be a component here which is responsible for load balancing the load here. So we can have users connecting to the load balancer, and they then on their turn will be connecting to certain containers that are run inside that environment. So the idea behind this is that the master node is going to pull containers from that container registry. So the master node now has a copy of the container images, and then based on what we configure, containers will be ran around this environment. Now, a Azure Kubernetes service, well, Kubernetes is a container orchestration solution. AKS, Azure Kubernetes Services, is a Microsoft managed Kubernetes service. Oh, and by the way, Kubernetes is also very often written down as K8S, meaning it starts with a K, then we have 8 characters, and then it ends with an S, right? So that is how this acronym works. Kubernetes K8S, or for example, my name is Alex, so I would be A2S. Huh? Or Microsoft, that would be M, and then iCrow would be 3, SOF would be 6, and then it ends with a T. Cool, huh? Yes, I know. Sometimes IT is weird, but hey, here we are. So, still learning about it. So, Kubernetes is also a solution that we could use in order to host our applications. Just in a simplistic form, I try to explain what that does. Other than that, sometimes a developer wants to write their code as functions, meaning we have an enormous amount of small pieces of code, like just a few lines that execute something. And then the idea is that we can in Azure host this also as a kind of a solution. Sometimes we want to be running our applications as functions, right? So typically this is very often referred to as function level applications. In Azure, we basically have two options to run functions. In Azure, first of all, we have something called the platform as a service a function. Okay, this is something happened to my font size. Here we are, platform as a service, function app that we can run, function app. Another solution is that we can also run a platform as a service logic app. Now, if you look at a function app, basically what's going to happen is that we can create still, we are going to create something called an app service plan. Let me just write that down, an app service plan, just like the one for a full application. However, this app service plan is going to be created in something that we call a serverless environment, meaning we don't need to think about sizing. We can still run it, and then on top of that, it will still create an app service, but that is going to be the function app. And then on top of that function app, we can just go in and so we can say, hey, this is our code. So here we have a piece of code created, and that is going to be a very small piece of code. And that is something that we want to be running in there. Right, so that is one way to run an application. In that case, those are very, very small pieces of code. Um, Short-lived, so they run like for seconds and then they kill, they die, and they are also triggered. So it's not a continuous cycle of running this code. When we need it, we trigger it, we use it, and we kill the code again. Another solution is where we are also making use of an app service kind of plan. However, in this case, we are running things on something called the Power Platform. It's just a different name in this case for being able to run a solution. And in there, we can run something called a logic app. Also here we can create a solution which we call serverless, meaning we don't need to think about sizing, just like in the other one. And then we create a logic app, and a logic app is pretty much a flow of actions that we can run in case of a certain situation. So we can go say, hey, you know what? We have some kind of a trigger, and then based on that trigger, we are going to take a couple of steps simultaneously, maybe, or in sequence. Um, and this is the nice thing about this is that where here we will be running with your own code, right? So this is where you will bring your own code. Then a logic app is sort of a no code solution, or sometimes also referred to as a low code solution, where you only have to do a little bit of coding. So the developer doesn't have to really create a lot of lines of text to execute software. It's just a little bit. So it works with predefined pieces of information, predefined pieces of code there. Sure, just a short demo on this. Let's say I want to create let's say a logic app here. Then let's go and create one. And then here we have options like, hey, how are we going to run that logic app? I'm going to choose a workflow service plan. Let's just create something simple. This is the simplest thing. And here we can then go in and say, hey, let's just go create that logic app. Let's name this logic app demo. This is probably already used by somebody else. This has to be a fully qualified domain name. So I'm going to go and say Ella demo. Is that allowed? No, that is too bad. Ella Azure demo. Is that allowed? Yes, so nobody thought of that name. I'm going to choose REST Europe for the location. This also is going to create an app service plan. And in this case, here I do have a couple of options on how to pay for this. Now, maybe this is something that, in my case, maybe I don't want to be paying for it in this way. So here but this is one way to do so. Let's just get started with something small. I'm going to leave it for now. And then basically what it's going to do, I'm going to allow public access. Let's see if I am allowed to create this. Let's create. Seems to be working. So let's see, let's hope it works in the end. But the logic app, basically what it allows me to do, it allows me to create a flow of steps that I can then automate. If you are a Microsoft 365 user, you may know about this app called Power Automate. And Power Automate is the exact same thing. You will notice when I am going to create my Logic app, there's a lot of so-called end user stuff that is part of the solution. A lot of end user stuff, meaning that we can, for example, have it connect to a mail account and to another mail account, or connect to OneDrive or Dropbox or Box, all kinds of things that it allows us to communicate with. So not the well, it's not like a super server kind of thing, but it works. You know, it's one way to go into that. Now I can imagine that trying to memorize all this stuff after just, you know, what is it, 1 hour of about in 1 hour of me explaining stuff may be a little bit much. So one of the things that you might find interesting here is there is YouTube, obviously, and on YouTube, here is my YouTube account here. And one of the things that
Hey there,
oh,
my name is Alex.
yeah. And here we can search for workloads as well. And here we have here is another video, basically the same thing, understanding workloads in Azure. What I could have done is just put this on. But this is also going to take you through those steps, right? So this gives you a little bit of an idea. I also have a couple of deep dives in, for example, how are we working with let's say virtual machines and so on. How are we working with, well, all kinds of things. So if you're interested, and obviously, if you are in this course, you have to subscribe to my channel, right? Because it's important. I need a lot of subscribers because that's good. So here we are. My Logic app is created. And then what I have is I can start creating the workflows in the Logic app. So I can go and add from template maybe. And this allows me to create logic apps with, well, all kinds of predefined solutions. So here we have a couple of templates like, hey, how am I going to, for example, connect different pieces of Azure to other pieces of Azure? So here we see examples of SharePoint or other kinds of connections based on a connector. You can go say, hey, you know what? I want to look at what Microsoft Teams has to offer, or for example, SharePoint. And then we can see a couple of templates that are related to, well, Teams and SharePoint. Here we have, for example, data, how to integrate SAP with Teams, or how to, for example, allow different components to connect to each other. So like this, so you could take, let's say I want to add one from, not from a template, and then I am going to create, let's say, a workflow real quick here. This will take me to the, this will in the end ultimately take me to a canvas where I can start building the solution. So here we have the designer that we can open, and we can then go in and start, well, creating by starting to create a trigger. And if we look at the trigger, then here we can see all kinds of triggers. So hey, in what situation should this flow or this logic app run? And here we have all kinds of things, including, well, end user stuff like Calendly or what else do we have? DocuSign or Entersoft or I don't know, other GitHub, Google Calendar. So you can see there's a lot of end user stuff. There's also a lot of server kind of stuff that we can use as a trigger. So you could create a situation where, for example, you could go say, hey, you know what? If, let's say, the current conditions change, and we can then create to, in this example, Amazon weather, we can then monitor for a certain location that if the temperature goes above a certain value, right? We can look at that then. So if, for example, in New York, United States, let's say as an example, United States, if at that location we can see something change here, then that is going to be my trigger here. So I'm going to look for stuff. How often do you want to check for this? In what time zone? We can monitor that stuff. In settings, we can then go and choose for things like connectivity. What does it look like, right? So what are we going to check? Here we have New York. If the current condition change, that would be one, right? So if there's any change, here we are. And then we can go and say, okay, that would be the trigger. Let's add an action then. And we can create an action, for example, by, well, maybe I want to delete data that I've stored in Azure. So if it starts to rain, delete data. I know this example is super stupid, right? But this is indeed explaining a little bit what the capabilities are, right? So you create a canvas. It will also get some code here as well. So what are we building? And just like that, we can create macros or if this then that kind of situations. Well, in a graphical way. Just an example of what a logic gap could be. So here we have it. This is what we can do if we want to be running workloads on Azure. This is just an overview of what the capabilities are.